All right, so we are going to be flipping to the multiplying decimals tab. Remember, we started taking the notes on top of the page here the last time, in the last lesson. And I said we're going to leave this problem down here for a different time. Now, when we are multiplying by a whole number, which we did in the last lesson, remember that whole number was down at the bottom or underneath the top factor, just like we did on the back side here. So we had our whole number here, our whole number here, and our whole number here. Okay, now we are going to be changing these whole numbers to decimals and multiplying a decimal by a decimal. So it's really actually the same process as multiplying by a whole number. However, you just have a couple more digits behind your decimal point to worry about in your side count, like what we were doing over here with these small numbers. Okay, so I'm going to show you on this example here first, and then we're going to move into the book and I'll show you some more practice problems through there, and then I'll assign you your homework. So let's line them up. Now, if you have decimal times a decimal, when you're multiplying, I always put the number with the greater digits on top and the number with the smaller amount of digits down below. So let's put these in here. And remember, we do not line up the decimal points. When we're multiplying, we line up the last digit.
Mr. Young, to the office, please.
Sorry about the interruption. Okay, so then I'm going to put my 5 under my 3. My 4 is going to go under my 2. My decimal point will go in between there. Okay, so now, same as last time, I'm going to multiply without worrying about the decimal yet, just like the first step up above says. So I'm going to multiply as if this was 23 times 45. So now 5 times 3 is 15. 5 times 2 is 10. Plus 1 is 11. 5 times 0 is 0. Plus 1 is 1. Now, because I have another round here, I need to put my 0 down below and multiply with the next round. 4 times 3 is 12. 4 times 2 is 8, plus 1 is 9. 4 times 0 is 0. Okay, now I'm going to add straight down, and I then get 5 plus 0, which is 5. 1 plus 2 is 3. 1 plus 9 is 10, carry my 1. 1 plus 0 is 1. All right, so now this is where I need to go back and worry about the decimal point. I need to count the number of digits behind my decimal point in my 2 original factors up above. So that means I have my 2, my 3, and my 5. Those are all behind a decimal point in the factors above. So I'm going to do my little number of 3 here so that when I get my product down here, my decimal point starts on the right-hand side. And I'm going to move my decimal point 3 places to the left. 1, 2, 3. Put my decimal point there, and my answer should be 1.035. Okay, so we are going to move into the book now and do quite a few practice problems there just to get the hang of it. And what is actually really nice is you most likely, or you've kind of already done these problems, you just have an extra set of decimal points or digits behind a decimal point to worry about. And that's the only difference between multiplying by a whole number with a decimal and a decimal by a decimal. Okay, so let's flip open to the textbook. You're going to open up to page 204 under the guided practice problems here. Okay, so I am going to show you, I'm going to solve these problems with you and for you, but I need you to copy them down into your book so that you have those examples in the book in case you need to look back at them. Okay, so let's line up our last digits here. So I have 0.6 times 0.5, and luckily these two are in the same, or have the same amount of digits in them, so it's easy to line up. All right. Let's do this. So 5 times 6 is 30. Remember, I'm multiplying the numbers by each other, but I'm ignoring the decimal point for a minute. 5 times 0 is 0, plus 3 is 3. Bring down my 0 to hold my spot. 0 times 0 is 0. 0 times 0 is 0. So now when I add, and I'm going to add 0 plus 0 is 0, 3 plus 0 is 3, 0 plus 0 is 0. And I'm going to go back and I'm going to count the number of digits behind my decimal point up above. So I have my 6 and my 5. Okay, so my 6 and my 5 are both behind a decimal point. So that means I need to move my decimal point in my product 2 places to the left. Okay, so now my answer becomes 0.30. Okay, let's move on to the next one here. This one's going to be quite a bit of multiplying. So what I'm going to do is actually do this on a separate sheet of paper here because I think I'm going to run out of room. You'll notice that as this unit goes on and as we go through 6th grade in this math book, they do not necessarily give you a lot of room to solve the problems. And so if that's the case and you ever need to use a loose leaf sheet of paper when solving them or just find an extra space, you're more than welcome to do that. Okay, so now I have, and I'm going to rewrite the problem just so I can see it here. Okay. So I get 27.43 times 1.089. So now I see that they both have 4 digits in them, so I'm just going to line them up with the digits that are there in order. Okay, so I'm going to start multiplying, and I'm going to multiply like I'm ignoring the decimal points first, and I'm just going to multiply straight across. So 9 times 3 is 27. 9 times 4 is 36, plus 2 is 38. 9 times 7, 63, plus 3 is 66. 9 times 2 is 18, plus 6 is 24. Bring down my 0. 8 times 3 is 24. 8 times 4 is 32. Oh, I'm sorry, plus 2, 34. 8 times 7 is 56, plus 3 is 59. 8 times 2 is 16, plus 5 is 21. Now I'm going to add another 2 zeros to hold my spot. This one is just going to be zeros straight across. Oh, 1, 2, 3 zeros to hold my spot, and then I can start adding. So then I have 1 times 3 is 3, 1 times 4 is 4, 1 times 7 is 7, 1 times 2 is 2. All right, let's add 7, 8 plus 4, 12, 6 plus 4 is 10, plus 1 is 11, 4 plus 9 is 13, plus 3 is 16, plus 1 is 17, 1 plus 2 is 3, plus 1 is 4, plus 4 is 8, 2 plus 7 is 9, and 0 plus 2 is 2. Now this is a really, really big problem. Your problems that you will be solving on your own will not, and I will repeat it, will not have this much multiplication to do with it. We realize that this takes a long time. Okay, so if you run out of room, don't worry about it. We are not going to give you problems that have this much multiplication in there. I just wanted to show you the long process of it, just so you have that exposure, but you're not going to be asked to do multiplication like this. All right, so then we got to go back to our original problem. We have 2 digits behind my decimal point here, 3 digits behind my decimal point here. So that gives me a total of 5 digits behind a decimal point in my original 2 factors that I'm then going to move over here. 1, 2, 3, 4, and my answer should be 29.87127. That is a very big decimal, okay? Like I said, we're not going to expect you to do problems that big. So if you just wanted to watch me solve this one, I should have given you that heads up beforehand, and I apologize for that. If you just want to watch it, you can skip this one, but at least you had some exposure so that if you want to challenge yourself, you're more than welcome to. So I'm just going to write the answer down, 29.87127. Let's try to find one that's a little less multiplication here. Let's go down to, let's go over to number 3. Number 3 should be one that we could solve in our book here with plenty of room. All right, so I'm going to put the factor with the more digits up on top, 0.98 times, and remember I line up my last digits. So my 3 is going to go under my 8, my 7 is going to go here, and my decimal point is going to go in between. Then we can multiply. Ignore your decimals for now, or just not yet, and then we will get to them in a second. 3 times 8, 24. 3 times 9 is 27, plus 2 is 29. 3 times 0 is 0, plus 2 is 2. Bring down my 0. 7 times 8 is 56. 7 times 9 is 63, plus 5 is 68. 3 times 0 is 0, plus 6 is 6. So let's add. I'm going to write my answer over here. 4 plus 0 is 4. 9 plus 6 is 15. 2 plus 8 is 10, plus 1 is 11. 1 plus 6 is 7. Okay, so if we were just multiplying as is, 98 times 73, we would get 7154. But now we have to go back to our original factors, count the number of digits behind a decimal point, and I see 3 digits behind a decimal point. So that means I'm going to move my decimal point 3 places to the left, 1, 2, 3, and my answer should be 7.154. Now if you think about it, we haven't done this with the last couple problems. This number right here, 7.3, is pretty close to 7. 0.98 is pretty close to 1. So that means we're kind of almost doing 7 times 1. So we should get around 7 as our answer. If we got 71.54 or 0.7154, then we would probably have to go back and look what we did for our decimal point. But our answer seems to be just estimating it quickly in the right spot. Our decimal point's in the right spot, and if we multiplied or added wrong, that would be an easy fix as well. Okay, let's move on to the next one, number 4. Now number 4 has 2.7 times 1.35. Sorry, I wrote over the original number here. So 1.35 has more digits in it, so I'm going to start with that one on top. Okay, then I'm going to put 2.7 here, and we're going to multiply. Remember, we multiply as if we're ignoring our decimal point. We'll add them back in at the end. 7 times 5 is 35. 7 times 3 is 7, 14, 21, plus 3, 24. 7 times 1 is 7, plus 2 is 9. Bring down my 0. 2 times 5 is 10. 2 times 3 is 6, plus 1 is 7. 2 times 1 is 2. We then add straight down. 5, 4, 16, and 3. So then we get 3, 6, 4, 5. Go back to my original problem and count how many digits I have behind a decimal point. I have 1, 2, and 3. Number, so that means I'm going to move my decimal point 3 places to the left. 1, 2, 3. My answer is then 3.645. Okay, so if you think about it, going back to our problem here, 2.7, pretty close to 2. If you then were to multiply that by something that's pretty close to 1, you should have an answer. Well, depending on how you rounded 2.7, you could round that to 3, you could round it to 2. your answer should be around 2 to 3. And it is. It's a little bit more than 3 compared to what our rounding was. But what our main goal with the rounding and just double checking at the end is so that we don't end up with 36.45. That would be a huge difference between somewhere around 2 and 3 for our answer and 36. Huge difference there. Okay, so just kind of think about it. That skill will come in handy once you get further into the curriculum too. Okay, now I am going to show you one problem with some zeros in there. This is called annexing a zero. You don't need to know that term, but I am going to show you just one problem, number 5 here, in case you come across one of these problems in your homework. Okay, so this one's going to have quite a few zeros in it. So I'm going to try to write really small down here. So these have each 3 digits. So I'm just going to line them up in order as they come, 0.09. We're going to multiply. So again, we ignore our zeros, or our decimal points, like we are multiplying 3 times 9. All right, so 9 times 3 is 27. 9 times 0 is 0, plus 2 is 2. 9 times 0 is 0. We have to bring down a 0. 0 times 3 is 0. 0 times 0 is 0. 0 times 0, 0. Now to bring down 2 zeros. 0 times 3, 0. 0 times 0, 0. 0 times 0, 0. Let's add. Well, we kind of know what's going to happen. So I'm going to add straight down, but I'm going to write my answer on the side over here so I'm not running into this problem down below. 7 plus 0 plus 0, 7. 2 plus 0 plus 0, 2. Then we have 0, 0, and 0. We can't ignore those zeros yet because we'll probably need them when we move our decimal point. So now I have 1, 2, 3, 4 digits behind a decimal point. Put my number, my decimal point on the right, move it 4 places to the left. And my answer is 0.0027. So that's what annexing a zero is. Like I said, you won't need to know that term, but zeros that are in between numbers in a decimal point, just like in here, 0.03, 0.09. These 2 zeros right here and right here hold a spot. Those are very important. I know you've worked with decimals in the past where if you have a 0 at the end of a decimal, like if you had, I'll write it right above here, if you had 0.030 and they just wrote in an extra 0 right there, you could ignore that 0 because that's at the end. That's not necessarily holding a spot. But this tucked inside of a decimal, and especially in between the decimal point and another digit, it is holding a spot. So that 0 is needed. Now this 0, you could probably argue, not necessarily needed, but when you're writing a decimal point down, it is needed because you want to show that it's less than 1. Okay, now I talked a lot. I apologize that this is quite a long video. If you need more practice, I will attach another worksheet. Like I said in the lessons past, the worksheet that I attached to this document here, or this assignment in Google Classroom, is not anything you have to do. That is to say, you just want a couple more problems as practice in case you're not quite confident in it yet, or maybe you come up to me and I say, hey, let's pull up this extra page that's on the assignment. Let's do some problems on there. That is what that is there for. Don't feel like you have to do those problems. Your homework for tonight is going to be, I'm going to move my book a little here so you can see. On the next page, page 205, and it is going to be problems 1 through 4 on 205. And then if you flip to the next page, 207, problems number 21 and 22. I will have this written down on the assignment so you can see that in person. Good luck, and just let me know if you have any questions. I know this is a long video, okay?